Good morning everyone. Today we will start new chapter Electrochemistry. It is chapter 2 class 12th. So general introduction it is given here. You can see the topic it is redox reaction. Actually what is the meaning of redox reaction? In that two words it is given redox, where reduction and oxidation take place. Okay, reduction means reduce, where charge will reduce. Okay, in oxidation charge will increase. Okay, if oxidation and reduction take place simultaneously, then this reaction it is called redox reaction. Okay, so it has two types: direct redox reaction and indirect redox reaction. If oxidation and reduction take place both in the same container, then it is called direct redox reaction. But if they need to separate beaker for carry out the oxidation and reduction, then it is called indirect redox reaction. So you can see here the difference between oxidation and reduction. In oxidation, loss of hydrogen take place, but gain of hydrogen take place in reduction. Okay, oxidation you can see here, as the name suggests, here gain of oxygen take place, but in reduction loss of oxygen. Okay, in oxidation loss of electron take place, in reduction gain of electrons. In oxidation increase in positive charge, in reduction decrease in positive charge. Okay, so these are the difference. You can learn very easily. Oxidation, reduction. Oxidation increase in positive charge, here decrease in positive charge. Gain of oxygen, gain of hydrogen. So you can see other name of oxidation it is called reducing agent, but other name of reduction it is called oxidizing agent. So whatever difference you are writing between oxidation and reduction, you can write between oxidizing agent and reducing agent. Now you can see few examples are given here. Zinc plus copper sulfate, it will react to form zinc sulfate and copper. Here zinc it is present. If alone element it is present, then it carries zero charge. Okay, when it will react with copper sulfate, it will give zinc sulfate, where zinc carry +2 charge. Okay, now you can see from reactant to product, if you will enter, then zinc to zinc sulfate, charge will increase. So definitely zinc carry out oxidation. In zinc oxidation take place. If one compound or one element carry out the oxidation, definitely the other will be the reduction. Two opposite cases will take place here. So you can see in ionic form zinc will convert into zinc ion, okay, and copper ion will convert into copper. Okay, again here you can see one more example. Copper it carries zero charge. When it will convert into copper nitrate, then it carry +2 charge. Okay, so copper 0 to +2, increase in positive charge, then oxidation will take place. Definitely in silver nitrate, reduction will take place. So you can see displacement reaction can be or cannot be a redox reaction. It depends whether oxidation or reduction take place. If take place, then it is a redox. Otherwise, it can't be redox. You can see single displacement reaction, it is a redox reaction. Okay, but if you will consider double displacement reaction, then it is not a redox reaction. Okay, so in displacement two types are there, single and double. Single always carry out the redox, but double displacement it is not the example of redox. Okay, so now you can see zinc when react with sulfuric acid, it will give zinc sulfate. Zinc carries zero charge, here it is carrying a +2 charge. So again charge it is increasing, then definitely it carry in this oxidation will take place. Okay, here zinc has been oxidized to zinc 2 positive ion, but if H2SO4 it is going to convert into hydrogen gas. So you can see in H2SO4 hydrogen carry H positive charge, in hydrogen gas it carry 0 charge. Here charge it is reducing, if charge reducing then reduction will take place. Okay, so oxidizing agent is the other name of reduction, where the substance get reduced, and reducing agent is the other name of oxidation, where substance get oxidized. If both oxidation and reduction take place, then it is called redox reaction. So you can define redox reaction as the reaction which is considered to be made up of two half reaction, in which one reaction carry out the oxidation and other will carry out the reduction. So you can split the redox reaction into two parts, in which in first half oxidation will take place, in other half reduction will take place. Here we can see what is the definition of electrochemistry. Actually it is the relation that shows between electrical energy and chemical energy. So chemistry, we can see na, it is the branch of physical chemistry which deals with the study of conversion of electrical energy from chemical energy. Okay, how you can learn electrochemistry? It means here chemical energy will convert into electrical. Opposite arrow you can keep, chemical to electrical. Today again we will continue the chapter 2, electrochemistry. In electrochemistry you will do the two types of cell. One is electrochemical cell, other name is galvanic cell or voltaic cell. Okay, and its second type it is electrolytic cell. In electrochemical cell you will convert chemical energy into electrical energy, but in electrolytic cell you will convert electrical energy into chemical energy. Okay, opposite case it will be here. So you can see, if you are going to convert chemical to electrical, then you will use the chemical energy of the compound into electrical energy. Then this reaction involves spontaneous reaction. But in electrolytic cell, you are going to convert electrical energy into chemical energy. You are using the energy of electrical, then you will get the chemical energy. Then that's why it is called non-spontaneous reaction, because you need some help from outside in the form of electrical energy, then only you can convert. So that's why it is called non-spontaneous reaction. Okay, this is spontaneous and this is non-spontaneous. So you can see electrochemical cell concept came from the study of redox reaction, in which both oxidation and reduction will take place. So how it came? First time the zinc rod was taken in the beaker, okay, that in which solution it was dissolved, that is of copper sulfate. Okay, so later on what they have observed, zinc it is slowly going to into a solution and forming a compound zinc sulfate. After reaction, when zinc react with copper sulfate, it will give zinc sulfate plus copper. Okay, so what they have observed here, zinc is going to oxidized because it carries 0 charge and here it carry +2 charge, and copper is going to reduce. It means whenever you will keep any rod into the solution, it will undergoes redox reaction, okay, in which oxidation and reduction will take place simultaneously. So on the basis of that they have made the cell. Okay, so you can see this reactions happens by its own, therefore it gives energy is negative. Okay, negative means this reaction will be the spontaneous. Okay, if del G is equal to positive, it means it needs some help, it needs some energy, then it is called non-spontaneous. Okay, work done by the system in electrochemical process is always negative. Why it is negative? Because it is spontaneous reaction. Okay, so one more formula it is given. Electrical work, it is equal to charge into potential difference. So we can learn the definition of galvanic or voltaic cell, that is the other name of electrochemical cell, the device in which chemical energy is converted into electrical energy by spontaneous redox reaction. So it is the exact definition for galvanic or voltaic cell. So this is the type of electrochemical cell, okay, in which you have to keep the two separate beaker, first beaker and second beaker. In first beaker they have kept the zinc sulfate solution in which they have dipped the rod that is made up of zinc, okay, and this solution, it is copper sulfate in which copper rod has dipped, okay. So here what will come? Zinc rod, okay. Zinc rod they have dipped into the zinc sulfate and copper rod into the copper sulfate, okay, and the two beaker, it is joined with the help of salt bridge, okay. Now here what you are providing there, voltmeter to for checking the reaction, calculation means reading, you can say here, okay. So you can see the first cell, that is in which zinc rod has kept into the zinc sulfate, it is called anode cell, and in which copper rod has kept into the copper sulfate, it is called cathode cell, okay. It is zinc rod. So after reaction, what you will see here, reaction, how reaction take place here. In first beaker, that zinc rod you have taken, in which oxidation will take place. So here zinc rod you have taken, so zinc will oxidize into a zinc positive ion, and here already what you have taken, zinc sulfate. So you can see when rod will dissolve into the solution, then zinc ion will be formed. Already zinc ion it is present there. It means in the solution positive charge will increase, okay. In anode half cell, which charge will increase? Positive charge. You can see in the diagram. Here what will increase? Zinc positive ion, okay. Here what you have kept? Copper rod and in a copper sulfate solution. From the solution, copper ion will deposit on the rod, okay. So from the solution what you have taken? Copper to positive ion, and it will deposit on the rod, and what will be formed? Copper. So you can say here na, in the solution positive charge will decrease. In anode half cell positive charge will increase, okay. In cathode half cell positive charge will decrease. So to balance the charge, we have to use the salt bridge, okay. In salt bridge, positive ion from the salt bridge, it will move towards the negatively charged particles. So here copper ion, it is going to decreases and sulfate ion going to increase. That's why positive part will move towards cathode half cell and negative parts will move towards anode half cell. So with the help of this, you can balance the charge. That's why we are keeping here salt bridge, which can balance the charge as well as it can maintain the neutrality between the two beaker. So actually what is the salt bridge? It is the U-shaped tube in which some ionic compounds are kept so that it can balance the charge or can maintain the neutrality. So now you can see here the difference between the types of conductors. First it is electronic conductors, okay. Other name it is metallic conductor. Electrolytic conductor, other name is solution conductors, okay. So according to the name as it suggests, electronic means electrons. It allows the current to pass in a metallic lattice by movement of electrons. Suppose you have taken the iron rod. Okay, if iron rod you have taken, then you know all very well every metals they are having electrons as well as kernels. Kernels means positive charge. So two opposite things it is kept here, okay, present in the all metals. So electronic conductors means it is due to the current, it will flow due to the movement of the electrons. And in electrolytic conductors where you have taken the electrolytic solution, so in that current will pass due to the movement of the ions. Okay, so definitely you have to take the solution of electrolytes. Second difference you can see here, there is only a physical change occur during a passage of current, but in case of electrolytic conductor there is physical as well as chemical changes. Okay, there is no breaking of ions. Okay, means it will not break into the ions. Third point, it generally shows no transfer of matter. It involves the transfer of matters in the forms of ions. Okay, if you will see, current can easily flow through the iron rod, but you are not going to break it. Okay. Fourth point, during the passage of current, resistance increases due to increase in the temperature. Why? If you will increase the temperature, in metals two things are present, kernels as well as electrons. Okay, kernels. So you can see it is carrying a positive charge, and electrons it carry a negative charge. If two opposite things come together in a same area, then you can say na, on increasing a temperature both will move in opposite direction and they will hinder the motion of each other. As a result of this, passage of current will decreases. Okay, now in fourth point of electrolytic conductor, during the passage of current, resistance generally decreases as there is decrease in degree of hydration of ions. If you will increase the temperature, okay, during increasing of temperature, during what will happen, ions motion will increase and current will increase. So here's reverse condition, here it is directly. So you can say temperature is inversely proportional to electronic conductor, but temperature is directly proportional to electrolytic conductors. Conductive power of metal is very high, but conducting power of electrolytic conductors is very low. So you can see electrolytes and electrolysis. What is the difference between these two? Electrolytes are the compounds, okay, or you can say it is the substance, okay, in which current can easily flow. So definition how you can write, when current is passed through the aqueous solution of a substance, substance will decompose into the ions and ions carry the current. So this is called electrolytes. Okay, and in which this process will take place, this is called electrolysis because it is occurring by breaking the compound on decomposition. Example of electrolytes are bases, acids and few salts, salt in water. These all are electrolytes because they will carry current when dissolved in water or they are taken in aqueous form, you can say aqueous form, or in molten state. So you can see higher is the value of dissociation constant, greater is the degree of dissociation, stronger is the electrolyte. So you can define two types of electrolytes, strong and weak electrolytes. Suppose you have taken the example of NaCl. 10 molecule of NaCl you have taken and 10 ions of sodium ion and 10 ions of chloride ion will be formed. Suppose it is formed, then you can say all molecules it has broken, it means it is a strong electrolyte. If you have taken any other compound, suppose AB, 10 molecules you have taken but only 6 has dissociated, it means 4 it has left, so it is a weak electrolyte. So you can say na, if complete dissociation will take place, then it is called strong, but incomplete it is called weak electrolyte. So you can define strong electrolytes are the substance which are largely dissociated and they are highly conducting. Okay, but weak electrolytes are the substance which are low conducting liquid, okay, and do not dissociate completely. Examples are given here: sodium hydroxide, sulfuric acid. Okay, these all are the strong electrolytes. Okay, in weak electrolytes you can take acetic acid, ammonia, amines. These all are weak. So you can see here very important concept. Dilution of solute follows Ostwald law of dilution for a weak electrolyte. If you will dilute the weak electrolyte, definitely the dissociation will increase, then conducting power will increase. So what are the factors influencing the degree of dissociation? Degree of dissociation of the electrolyte in the solution. How you can get? It is represented by alpha. Degree of dissociation represented by alpha. Mole dissociated by at any time divided by total moles present at t is equal to 0, means at time t where it is 0. So variation of the alpha of the electrolyte is directly by, how you can explain? By taking the concept nature of solute. If any compounds you will take, if it is strong, then degree of dissociation will increases. Okay, it also depends upon the nature of solvent. So you can see solvent having high dielectric constant are themselves feebly ionized, but electrolytes in high dielectric constant solvent shows high degree of dissociation. Dielectric constant means which is having a ability to dissociate the solute into the ions. So if having more value of dielectric constant, then more will be the ability to dissolve. So next factor it is dilution. The extent of dissociation of electrolyte also depends upon dilution. With increase in dilution, if you will add water, then more and more dissociation will take place and conducting power will increases. Next factor it is temperature. So dissociation power it will increase with increase in temperature also. If you will increase the temperature, the ions will separate out. Okay, there is no hindrance in the movement of the ions, definitely the conductance power will increase. Okay, addition of other species. If you are adding other species having an ion common to that of weak electrolyte, shows a decrease in degree of dissociation. It means if you will add common ion into the solution, then degree of dissociation will decreases. So finally you can take this concept. If you have taken the process of electrolysis, then electrical energy will convert into chemical energy. But in case of chemical energy will convert into electrical energy. So it is very important concept. So in next lecture we will do the topic electrolytic cell. The other name it is voltmeter. So you have to do up to this only. Thank you.